Welcome guys to a new video. This is a paper 1 question, normal distribution. Let's have a look. The lengths of the seeds from a particular mango tree are approximated by a normal distribution with a mean of 4 centimeters and a standard deviation of 0.25 centimeters. A seed from this mango tree is chosen at random. Part A, calculate the probability that the length of the seed is less than 3.7 centimeters. Okay, so first of all, let's write this data as x given the length of the seed, which is normally distributed with a mean of 4 and the variance of 0.25 squared. So the variance is standard deviation squared, hence 0.25 squared. Probability that the length is less than 3.7. Probability that x, which is the length, is less than 3.7. We go to the normal CDF on our calculator. And there we're going to have the lower bound as negative infinity. And by the way, if you have trouble visualizing this and making sense of this, always have a sketch, something like that, normal distribution, put the 4 in the middle, then put the 3.7 illustratively over here. This is what you want. Remember that theoretically this extends to negative infinity and positive infinity. We represent the lower bound as a ridiculously large number, which would be this one. Minus 9 times 10 to the power 99, as you can imagine, is crazy large. In the negative direction, 3.7, because that's the upper bound of this region that I shaded. And then the mean is 4, standard deviation 0.25. We let the calculator do the magic, and that's going to be 0.115. That's it. That's part A. Let's have a look at part B. It is known that 30% of the seeds have a length greater than k. Question B, find the value of k. Okay, so question B. I'm gonna draw this because I like to draw normal distributions, makes it easy to follow. I have my 4 over here. Then I have 30% of the seeds have a length greater than k. I have a certain k value and I want 30% to be above that. I know that half of this, like this half and the other half, is going to be 50% each, because this is a symmetrical distribution. I just want 30%. Let's say, hypothetically speaking, this would be our 30%. So this is 30%. I want a certain value k over there. How can I find this value? Well, I will do the following. I will use the inverse normal. I will say that k equals to inverse normal, which is also on our GDC in the probability distributions. And then the GDC will ask for the area. The area that I have to put is going to be the area to the left side of the value k, which is 70% or 0.7. Then it asks for the mean, which is 4, and the standard deviation 0.25. With all that being said, the answer would be 4.13. That's 4.13. That's another question solved. Then we go here to question C. For a seed of length d centimeters chosen at random, this thingy holds true. Find the value of m. Okay, so I'll just solve it over here. I want to draw this. I will have a certain d that's going to be between two thresholds, 4 minus m. Let me put this threshold here, 4 minus m, 4 plus m. Since this is a symmetrical distribution, I can infer that these values must be equal, and the probability of being between the two thresholds is 0.6. It says over there. So 0.6 is over here. I have 0.4 left, distributed over two pieces, 0.2 and 0.2. So the area below the curve must add up to 1. That's perfect. We have that. Now, how can I solve this? Well, I'll just consider the 4 minus m as a certain constant, just like I considered the k over here in the previous question. It's the same thing, except instead of k, I have a 4 minus m. It's still a number I'm looking for. So I will treat the 4 minus m as a constant I'm looking for, and I'll be using the inverse normal. So I will say 4 minus m equals to the inverse normal. Remember, whenever you need a number to find in the normal distribution, you use the inverse normal. Whenever you need to find the probability in the normal distribution, you use the normal CDF. Easy to remember, okay? The area to the left side of this number, that's 0.2. And then the mean, which is 4, standard deviation 0.25, nothing else changes. We work this out, we will get the value of 3.78959. And then by doing a simple subtraction, 4 minus 3.78 and so on, we get the m, and the m is going to be 0.2110 rounded to 3 significant figures. Hope this all makes sense. We are done. If you like the video, please drop it a like. If you follow the AI higher level course, make sure to subscribe. I'll see you guys in the next one. Bye.